Imagine you are looking at a galaxy, hundreds of billions of stars all orbiting around a common center held together by gravity. Now imagine that you measure how fast those stars are moving, and you discover something strange. They are moving so fast that based on everything you can actually see, the galaxy shouldn't be able to hold itself together. In fact, if the only thing producing gravity were the stars and gas we can see, many galaxies should have flown apart a long time ago. So, what is holding them together? The answer appears to be something we cannot see. Something that doesn't shine, something that doesn't seem to absorb or emit light, and something that may make up roughly 85% of all the matter in the universe. We can call it dark matter. And one of the scientists who helped turn this from an astronomical curiosity into one of the biggest problems in modern cosmology was Vera Rubin. But this isn't just the story of dark matter. It's also the story of a woman who wanted to study the universe at a time when scientific establishment was not always particularly interested in letting women do that, and perhaps ironically, the universe didn't seem to care. Vera Rubin was born in 1928 in Philadelphia. As a teenager, she became fascinated by the night sky. According to accounts her early life, she would lie in bed and watch the stars through a window. Not exactly the most efficient way to study astrophysics, but apparently it worked. She eventually attended in Vassar College, where she studied astronomy. And then came the first problem. In the late 1940s, astronomy was still overwhelmingly dominated by men. Rubin applied to Princeton for graduate study in astronomy. She was rejected, not because she wasn't talented. The problem was that at the time, Princeton did not even admit women into its graduate astronomy program. So Vera Rubin went elsewhere. She earned a master's degree at Cornell University, where she studied under some of the leading physicists of the time, including Richard Feynman. She later completed her PhD at Georgetown University, but throughout her career, Rubin repeatedly encountered barriers that had little to do with her scientific ability. She was sometimes denied access to facilities. She was sometimes the only woman in the room. And she became increasingly aware that astronomy was not exactly designed with a woman in mind. But Rubin had something that's often more useful than being welcomed into a field. She kept showing up. Now let's get to physics. To understand Vera Rubin's importance, we need to talk about gravity. Imagine our solar system. The planets orbit the sun, and the further planet is from the sun, the slower its orbital speed generally becomes. But when Vera Rubin and her collaborators began measuring the rotation of spiral galaxies in detail, they found something surprising. The outer stars were moving too fast, and they were not slowing down in the way astronomers expected. Instead, the rotation curves of many galaxies remained remarkably flat. The further you go from the galactic center, the stars just keep orbiting at roughly the same speed, and this creates a problem, a very big problem. Because if all the mass in the galaxy were concentrated in the stars and gas we can see, the outer stars should be moving more slowly, but they are not. It's almost as if the galaxy contains a huge amount of invisible mass surrounding it, a massive invisible halo. Rubin's observations provided some of the most compelling evidence that this unseen matter was not just a mathematical trick. It appeared to be real. Now, before before we get too excited, let's clarify something. Vera Rubin did not single-handedly discover dark matter. The idea of unseen matter was much older. In 1930s, astronomer Fritz Zwicky studied motions of galaxies in coma cluster and argued that there must be far more mass present than could be accounted for by the visible galaxies. Later, other astronomers found additional evidence for unseen mass. So, the story is not everyone was completely wrong and Vera Rubin appeared and invented dark matter. Science is rarely that simple. Instead, Rubin's work was enormously important because she and her collaborators produced detailed observations showing that the problem was widespread. Galaxies were rotating in a way that strongly suggested the presence of much more mass than we could see. And this was not happening in just one strange galaxy. It was happening again and again. The universe seemed to be telling us, congratulations, you can see the stars. Unfortunately, you are missing most of the mass. And this is where Vera Rubin's work reaches far beyond the rotation of individual galaxies. Today, dark matter is one of the central components of the standard cosmological model, known as lambda-CDM. According to this model, the universe contains ordinary matter, the stuff that makes stars, planets, and people. It also contains dark energy associated with the accelerated expansions of the universe, and somewhere in between, in terms of cosmic importance, is dark matter. Dark matter does not appear to interact significantly with electromagnetic radiation. That's why we do not see it directly with telescopes. But gravity doesn't care whether something shines. Gravity responds to mass and energy, and we can detect dark matter through its gravitational effects. We see its influence on galaxy rotation. We see evidence for it in galaxy clusters. We see its role in gravitational lensing, where massive structures bend the path of light. And we see its fingerprints on the cosmic microwave background, the relic radiation left over from the early universe. Dark matter also plays a crucial role in the formation of cosmic structures. In the early universe, tiny fluctuations in density grow under gravity. Dark matter, because it doesn't interact with light in the same way ordinary matter does, could begin forming gravitational structures early on. Ordinary matter then fell into these gravitational wells. Over billions of years, this helped produce the cosmic web of galaxy and galaxy clusters we observe today. So when we look at a galaxy, we are not just looking at a collection of stars. We are looking at the visible part of a much larger gravitational structure. The galaxy we see may be the only luminous tip of an enormous invisible iceberg, except this iceberg doesn't have the destiny to melt. Here is the fascinating part. We still do not know exactly what dark matter is. We know that something is producing gravitational effects. We can measure those effects with extraordinary precision, but the fundamental particle or particles responsible for dark matter have not yet been identified. We've proposed many possibilities. Weakly interacting massive particles, axions, astral neutrinos, and several other candidates. We've built enormous detectors deep underground, and we've searched these skies. We've smashed particles together at the Large Hadron Colliders, and so far, nothing conclusive. Which means Vera Rubin's legacy is a little unusual. Her observations helped establish one of the greatest mysteries in modern physics, but they didn't solve it. In a way, she helped us discover the question, and we are still trying to find the answer. Now we come to a more uncomfortable part of this story. Vera Rubin never received the Nobel Prize in Physics, and this has been the subject of considerable discussion. Her work is widely regarded as a foundational to modern astronomy and cosmology. So why didn't she win? The Nobel Committee's deliberations are confidential for 50 years, so we cannot simply look inside the committee's decision-making process and say this was the reason. But we do know something else. Rubin built her career in a scientific culture where women faced significant barriers. She encountered institutional discrimination. She was often excluded from opportunities that were readily available to male scientists, and she became a prominent advocate for women in science. She famously argued that science needs more women, and she worked actively to support younger female astronomers. So when people ask whether sexism played a role in Rubin not receiving a Nobel Prize, it's important to distinguish between historical evidence and speculation. We cannot prove that the Nobel Committee rejected her because she was a woman, but we also cannot ignore the fact that she worked in an era when gender discrimination was very real and well documented. And the broader question remains, how many scientists, especially women, had their contributions undervalued simply because the scientific culture of their time made it harder for them to be heard? This is the question worth asking. Today, astronomers are mapping dark matter across the universe. The Vera Rubin Observatory, named in her honor, designed to conduct an unprecedented survey of the southern sky. Its legacy survey of space and time, or LSST, will repeatedly observe billions of astronomical objects. It will help us study galaxies, gravitational lensing, transient phenomena, and the large-scale structure of the universe. And perhaps fittingly, it may help us understand the very thing that made Vera Rubin's work so important in the first place, the invisible universe. Vera Rubin once said, "In science, we do not have to know everything. We just have to be willing to learn." And perhaps that's the real lesson of her story. Sometimes the most important discoveries do not give us answers. They give us better questions. Rubin looked at galaxies and realized that the universe was not behaving the way our theories predicted. She didn't look away. She didn't decide that the data was inconvenient. She followed the evidence, and what she found forced an entire field reconsider what the universe is actually made of. Today we have a much better picture of the cosmos than we did in Rubin's time, but the majority of the matter in the universe is still invisible to us. We do not know what dark matter is. We do not know whether it is made of one particle, several particles, or something even more exotic. And we still have a lot to learn. But every time we look at a galaxy and see stars orbiting far too quickly, we are reminded of Vera Rubin, the woman who looked at the universe and noticed that something is missing. If you enjoyed this video, consider subscribing, because the universe is full of mysteries and apparently it has a very bad habit of hiding the important stuff. See you in the next video.